Let's take a look at oxidation of monosaccharides. Okay, so what we have here is we have the deconfiguration of aldose. Okay, just a simple monosaccharide. Now, when we have this open chain form, okay, when we have this open chain form of this monosaccharide, it can go through oxidation. Okay, when it goes through the oxidation, so it takes this aldehyde group, goes through the oxidation, it'll transform from the aldehyde into a carboxylic acid. Okay, now we do this by using Benedict's reagent. Okay, we use Benedict's reagent. Okay, which is a solution of that contains copper ions, the copper 2+ ions. It's a real bright blue color. When the Benedict's reagent goes through, it gets reduced and you get a kind of a brick red, deep red, burgundy color precipitate, because the copper is reduced to a +1. Okay, so it goes from this +2 to a +1 phase. It makes a dark red. Okay, a dark red color is what it makes. And it takes that sugar and it changes it into a carboxylic acid. Now, when it gets changed into a carboxylic acid, we have to change the name of it. So instead of being aldose, it will be altronic acid. Okay, and it will still have the D configuration, so to say. Okay, so it'll still have the structure here. 1, 2, 3, 4. Okay, it will still have that same look to it. The difference is that the aldehyde has become a carboxylic acid. So here we have the carbon with the double bonded oxygen, okay, similarity, but that H is now an OH, and there is that carboxylic acid group, that C double bonded O, OH. Okay, so oxidation of monosaccharides, we take our open chain monosaccharide, it's got that aldehyde group here at the end, so it can easily be oxidized. Again, we add Benedict's solution, oxidizing agent, boom, we get our carboxylic acid. There's that additional oxygen coming in, so the oxidation, remember, means to increase the number of carbon-oxygen bonds, increase the addition of oxygen, and we get this brick red precipitate, okay, for the oxidation of monosaccharides. Ketones don't readily go through oxidation, so the ketoses don't regularly do it, but some can take that second where their carbonyl is on that second carbon and can rearrange it and put it up in that first position and become oxidized.